It's a 37-ton RuggedMade log splitter that I've put adjustable wedge on. It's a little bit different than the ones you've probably seen, but if you've been around log splitters, good log splitters, then you'll know where this idea came from. But I wanted to do a wedge design that wouldn't drive and allow the multi-wedge to come up off of the stationary wedge. So I came up with this idea to I wanted like a 3/4 plate or 1 inch, but I didn't have anything that big, so I ended up using 1/4 inch plate and sandwiching them together to a 3/4 thickness, so it's a laminate, and it goes down and catches that pin on that bell crank. It's got a 6-inch throw, 1.5 bore cylinder. Nothing special about it. Just tried to find the lowest cost one I could get. I got these for, I think they were 120 bucks or something a piece or something like that. But all the bell crank is 3/8 1.5 inch flat bar, and then I just took the pieces and cut them up, punched holes in them, and before I actually did this design, I laid down a piece of like cardboard and did some right angle drawings with a compass, and kind of came up with what I perceived as being close to how big that bell crank would need to be for that 6-inch throw. And then I knew once I got it really close, I could adjust this piece up or down on this and get it fine-tuned. But what I did was, you take the tongue all the way off, and the original leg, get rid of that thing, and then you just take I'll see if you can see that. Take a flat, a 1/2 inch, 1.5 flat 1/2 inch. I had a bunch of 1/4 inch, so I took 2 1/4 inch plates and made a 1/2 inch plate, and then welded them and basically extended this bottom part of this beam forward so that I could have something to build the tongue off of and guide this thing down through. So I slotted this 3/4 by 4 inches. These pieces are 4 inches. Then I left it long enough where I could, once I tied this together, I could set this tube on it, because there's originally a tube that goes through here and locks in with this bolt. You have to get rid of it to put this in. But really, just about every adjustable wedge that people do, you gotta alter this somehow, because most of the guys put a cylinder pointing up, but then that cylinder just got a rod that goes up into a piece of pipe, and then it allows this to free float all the time. I didn't want it to free float all the time. I wanted it to lock in as soon as I engage it. So figured I'd follow that RuggedMade design and put it on this splitter, and it seems to work pretty decent. It was a little bit of a challenge to figure out all the geometry and all that stuff, because I'm not all that great with math, but I'm able to work it out. But this is what she looks like. You got an extra valve over here, and this is just a regular log splitter valve, and you just back the detent off, and it just allows this to be a regular spool valve. It goes in line with them without switching valve design, so it kind of works out nice to use a valve like that, because it just fits the design nicer. And I just took a plate, punched holes in it, and then made a flat plate, and then take a little piece of angle like that, and that way you can get all this bolted up, have this thing close, and then put that angle right up to it, and then tack it all together. And then I took it all back down, painted it all except for these spots right here, and then bolted it back up, and then welded it here and on the back side. That made it pretty simple to do that, but it's a pretty neat little design. I put extensions on this trays because I'm building a conveyor right now, and I want it to trough it into the conveyor trough. There's the 6-way right there. You can see the 3/4 laminated together. That wedge right there is a little bit more tricky to use on a design like this that locks, because these wedges push away from each other. So this wedge will actually wedge between the beam right here and this as it pushes it down. So you got to be careful with the 6-way. When you start in, you got to lift it a little bit and give it a little bit of room. Otherwise it could bind and tweak it a little bit. But there's what it looks like on the back side. Said all those pieces were all punched out. I used I don't know if most fabricators even know what an iron worker is, but I use this 65-ton iron worker, and you can punch all the holes and slot and do a bunch of stuff with that. It makes it nice for working with flat plate, but that way you can get all the pins pretty tight and everything, so you're not trying to drill and, well, not that a drill hole wouldn't be tight, they are, but it's just nicer to use the iron worker when you have it. So you try to use as much flat plate as you can to make it easier. But I'll go ahead and fire this thing up and show you how it works. All the way up, a little about 3/4 up. So the top of this wedge is about right here somewhere. We want it to really go any much more than that. Don't drive. Badly locked in there. And the 4-way's nice because the 4-way drives away. It doesn't drive down into the beam. So this is a little bit nicer. Don't worry about it so much. this is wedge in between because this wedge drives down. The 6-way definitely needs some room on the bottom with that wedge driving down like that. Might need to do a little bit of wedge designing, but it works. You just gotta grab the lever and release it a little bit. But overall, it's a pretty neat thing. Like when this wedge would drive up, when it's floating, it lifts that wedge up, and then that arm don't line up. So you gotta clear it. So just kind of recap some of this stuff and talk about maybe a little bit of these hydraulics, because I didn't mention that before. You can get away with about a 60-inch hose on these, would work for both of them. Number 6 JIC fittings. You could probably use 1/4 inch if you wanted. On the cylinder, those little fittings right there were a little tricky to find. I had to go searching for them. The plates that I made for those tabs right there were 3/8. Actually, those pieces were from the plate that I cut off of the tongue. I just cut it back up. There's the remainder of it right there. I just sheared it off in the iron worker and nipped out the 2 tabs for that piece. But yeah, you'll need some pretty good heavy duty iron to make this work out. It's not going to be, well, if you're going to try to attempt this, then you know what your abilities are. You don't want to do this if you're using some little pea shooter welder. You want to have something that's going to weld pretty decent, or have somebody that can weld it up for you pretty decent. You got to have something that's going to burn it pretty good. I use a Miller-Matic 210, and that's a 220 welder. It burns pretty good. So for big stuff like this, it works all right. Like I said, you're gonna need some, at least 1/4 inch plate to double up some stuff. Various pieces of, yeah, I mean, on anything like this, the thicker the better. Like I said, these pieces I put on right here to span the plate to the beam, those are 3/8. And then the piece I put on the tongue is 1/4 inch. Yeah, 1/4 inch. So I didn't really use anything under 1/4 on it, but if you guys want to try to attempt this, if you got any questions, I'd be more than willing to try to help you out. So write in the comments below and try to guide you if you're wanting to try to tackle something like this on your splitter. Like, share, and subscribe. Everybody have a good one.